Genetic engineering. Genetic engineering is the direct manipulation of an organism's genome using biotechnology. An organism that is generated through genetic engineering is considered to be a genetically modified organism. The first genetically modified mice were generated in 1974. In 1994, genetically modified food began to be sold, and in December of 2003, the glowfish became the first genetically modified pet to be sold in the United States. Perhaps one of the most recognized genetically modified organisms is Dolly, the domestic female sheep. On July 5th, 1996, Dolly became the first mammal to be cloned from an adult somatic cell using the process of nuclear transfer. Dolly would go on to live her entire life at the Roslin Institute in Edinburgh, Scotland. During Dolly's lifetime, she was bred 3 times that produced 6 lambs, all which would go on to live healthy lives. On February 14th, 2003, Dolly was euthanized because she had a progressive lung disease and severe arthritis. Although Dolly's life expectancy was to be somewhere between 11 and 12 years, she ended up only living 6.5 years due to illness.
The headline on the other major news story today, to which we intend to devote some time, is very simple. Hello, Dolly.
In February of 1997, a Finn Dorset sheep named Dolly sent waves of future shock around the world.
The first living, breathing clone of an adult mammal.
It's possible we're seeing a scientific explosion comparable to the atom bomb or the moon rocket or DNA itself.
For many, it was a case of science gone too far.
Are we acting more like the creator than creatures? Are we trying to play the role of God in all this?
Predictions multiplied about just what this breakthrough would bring.
Soon it will be possible to give her thousands of absolutely identical sisters.
Animals could be cloned with human diseases and new therapies tested on them.
Endangered species can take heart.
This is not an elaborate, sophisticated technique. It means that any decent college or graduate school student could potentially clone a human being.
Whatever became of Dolly, and all that speculation about the brave new world she ushered in. On July 5th, 1996, Scottish scientist Ian Wilmot received the news he had been waiting for. Lamb number 6LL3 had been born.
First of all, I was immensely relieved that she was alive and apparently normal. There was a slight feeling of sort of awe, if you like, at the potential impact.
Wilmot and his team at the Roslin Institute outside of Edinburgh had spent several years trying to do what no one had before: to successfully make a clone of an adult mammal.
Genetic modification may sound important for animals, but it becomes even more complex and important when we talk about engineering the human genome. An important question arises from this concept. At what point have we gone too far? When we manipulate our genetics too much, we may leave our natural humanness behind. There are definitely some benefits to the concept. No one would argue against fixing terrible disorders such as Tay-Sachs, autism, and Down syndrome. Autism is a neurodevelopmental disorder characterized by impaired social interaction, verbal and nonverbal communication, and by restricted and repetitive behavior. It has a strong genetic basis. Although the genetics of autism are complex, it is unclear whether autism is explained more by rare mutations or by rare combinations of common genetic variants. Down syndrome also known as trisomy 21, is a genetic disorder caused by the presence of all or part of a third copy of chromosome 21. It is typically associated with physical growth delays, characteristic facial features, and a mild to moderate intellectual disability. The average IQ of a young adult with Down syndrome is 50. This is equivalent to the mental age of a normal 8 or 9-year-old child, but can also vary widely. Tay-Sachs is a rare autosomal recessive genetic disorder, and its most common variant, also known as infantile Tay-Sachs disease. It causes a progressive deterioration of nerve cells and of mental and physical abilities that begins around 6 months of age and usually results in death by the age of 4. There are countless other disorders that could possibly be changed by use of genetic modification, but these are a few of the worst and most common. All of these horrible disorders could be fixed and maybe even eliminated from society, but how far is too far? If we can successfully fix problems genetically, what is to stop us from changing a perfectly normal human being into a superhuman? As a superhuman, we might have the ability to achieve both physical and mental acuity, but will we be leaving our humanity behind?
While being a superhuman may be an end result, we're not quite at that stage of research yet. According to the case that we researched, it was only in February of 2014 that in Berkeley, California, an advisory committee of the Food and Drug Administration began meetings to consider radical biological procedures that, if successful, could produce genetically modified human beings. The FDA calls these procedures mitochondrial manipulation technologies. The procedures involve removing the nuclear material either from the egg or embryo of a woman with inheritable mitochondrial disease and inserting it into a healthy egg or embryo of a donor whose own nuclear material has been discarded. Any offspring would carry the genetic material of 3 people: the nuclear DNA of the mother, of the father, and of the mitochondrial DNA of the donor. Roughly 1,000 to 4,000 children born in the United States each year, according to this article, will develop a mitochondrial disease, most by the age of 10, with symptoms that can range from mild to devastating and deadly. Most of these mitochondrial diseases prevent mitochondria from converting food into energy and are the result of genetic abnormalities. Recently, many scholars and scientists have adopted a policy that we should carefully and thoughtfully apply the tools of human genetic engineering to treat medical conditions in people, but we should not use them to manipulate the genetic traits of future children, such as their athleticism, musical talent, intelligence, and other such factors. Researchers at Oregon Health and Science University have produced 5 macaque monkeys using one of these techniques. 4 of these monkeys are now adults, and all 5 appear to be healthy. However, we won't know for years how subsequent generations may be affected, as these mitochondrial treatments would affect generations from the procedure. The FDA advisory panel says that the meeting would consist only of scientific aspects of mitochondrial manipulation and that any ethical and social policy issues are outside of its scope. However, we do need to consider in this class what these procedures might have in terms of ramifications. What we need to keep in mind is that within this case,
genetic engineering is being used as a treatment and is not as controversial. Within this case, the mitochondrial treatments are more akin to an organ transplant than they are to genetic manipulation of physical traits. At the same time, these treatments could lead towards more progressive genetic manipulations of children in the future and could have excessive ramifications for generations down the road as we develop more and more ability to manipulate the genetics of human species.
To gauge the general public's opinion, we interviewed several individuals and asked them specifically for their opinions on genetically modified babies, which is the topic of discussion for a case study. One individual was intrigued about the idea of genetically modifying babies and saying that it would definitely be useful for curing genetic diseases that we currently don't have a solution for today. Though the interviewee brings up issues regarding the possible unequal access of this technology to everyone in society, in this, he sees that rich people, for example, may have the resources to produce super babies, while poor couples will not. Obviously, everyone wants the best for their child, and so is it right to let money and power to be a deciding factor of who gets to have access to this revolutionary technology? Other individuals were of course against genetically modified babies. Specifically, one interviewee saw it as a natural. She felt that picking out traits for a baby made it seem like we were gods. She also added that it would be unfair to people that do not have access to the technology. Interestingly, she was an advocate for using genetically modified babies to help cure diseases, but using it for eugenics, not so much.
And I could spend forever in your